Good morning. My name is Harjap Singh and I will be today presenting my research project titled Detecting and Modeling Mental Health Symptoms Using AI and User Generated Text. This project explores how artificial intelligence, particularly large language models, can be used to detect, interpret, and model emotional and psychological signals from public online forms. And this project is supervised by Dr. Indu Bala. Moving on, this project investigates how AI can support early detection of mental health symptoms through online user content. The core idea is to combine large language models with psychological theory to bridge the gap between computational models and human experiences. By analyzing data from platforms like Reddit and Beyond Blue, we aim to build AI systems that can understand, track, and contextualize emotional distress in online communities. The motivation behind this is that mental health challenges are rising globally, yet access to timely professional help remains limited. Online communities like Reddit and Beyond Blue have become spaces where individuals express distress before they seek clinical support. So these posts hold subtle linguistic cues like expression of sleep loss, hopelessness, or anxiety, which can act as early emotional sensors. The opportunities lies in using large-scale natural language processing to responsibly analyze these signals and identify emerging mental health patterns at the population level. So the background, recent studies have used bird-based models such as Roberta to classify depression and anxiety-related posts with strong accuracy. However, many approaches rely only on linguistic embeddings and lack psychological groundings. My framework integrates AI driven emotion detection with psycholinguistic and effective modeling, creating a more holistic understanding of online emotional expression. This fusion between computational and psychological approaches define the uniqueness of this work. So I will bridge some research gaps which were not being seen. The main gap is that the most existing emotion detection models don't account for how emotions evolve, relate, and interact psychologically. So I have made my objectives that to detect multi-level emotional expressions using fine-tuned transformer models, which will help us to know what the user is feeling through their posts, and we will map these emotions into psychological space via circumplex model of effect, and then I will analyze emotion trajectories and symptom interconnections through network modeling. Altogether, this framework aims to move from just detecting emotions to interpreting them in contexts so that wherever the help is needed, we can give it. So, I have proposed a pipeline, and this pipeline takes the raw text and moves step by step towards psychological insight. We begin by data collection and pre-processing, followed by sentiment analysis for baseline polarity, which will tell us that the emotion is negative or positive. Next, the emotion and symptom detection, which will use models like Mantelbert and Roberta with Go emotions. The detecting emotions are then projected into valence arousal space for psychological interpretation. After that, we will do psycholinguistic profiling with Empath and DLATK, which are the libraries, which adds linguistic traits like self-focus and tones. And finally, we will do network modeling, which will reveal relationship between symptoms and users, leading to interpretable emotional networks. Moving on, this is my first step. In my first step, I collected around like 45,000 Reddit posts from subreddits like depression and anxiety, and after that, I collected 12,000 Beyond Blue forum entries using Pro and another Python scrapers. After that, I cleaned the text using Spacey library, which removed punctuation, links, and stop words. After that, each post was tokenized, normalized, and lemmonized to ensure consistency for model input. This pre-processing allowed us to build a unified dataset for both sentiment and emotion analysis. After that, when I cleaned the data, I also ran exploratory data analysis to see what I have got in my dataset. and the data was quite well. After the explorative data analysis, before dividing into complex and emotion detection, I first conducted sentiment analysis to establish a baseline emotional polarity, essentially whether users express positive, neutral, or negative tone in their posts. This step was crucial for two reasons. First, it validated that our dataset genuinely captured emotional experiences rather than random discussions. And second, it provided a benchmark for comparing how well later multi-motion models capture finer distinctions. I have used two models in this. The first is Radar. It's a rule-based model optimized for social media, which detects intensity of tone using lexical cues like happy or terrible. And another model I used was Distilbert, a transformers-based sentiment model that interprets deeper contextual meanings such as sarcasm or multi-sentence emotions. The combination of lexical and contextual analysis ensures reliability even when post contains subtle and conflicting emotion. After that, when I ran, I got the results. The results confirmed what we expected from the mental health discourse. The majority of posts exhibit negative polarity with smaller clusters of neutral and positive tone. Specifically, the radar shows stronger polarization, labeling many posts as highly negative due to keywords like can't sleep or feel numb. The distilled word, however, captured contextual nuisance, identifying mixed emotions where users express both distress and hope, such as feeling anxious, but I am trying to stay calm. These sentiment distributions not only validate data quality but also highlight linguistic variability across communities. For instance, Beyond Blue Post leans slightly more towards neutral compared to Reddit because they got the stop words policy on their website and people can't use many words which they usually use in Reddit. This analysis gives us the quantitative foundation of later emotion classification, ensuring that what Mentalbot and Roberta models detect emotions like sadness or joy. Those predictions are grounded in pre-verified emotional tone. Moving on, after sentiment analysis, we moved on to multi-level emotion classification. In this, I used three models from the Hugging Face website. The mental word model, which was already pre-trained on the mental health data, and I further fine-tuned it on Go Emotion dataset. The Go Emotion dataset basically had 28 emotions, including the neutral ones. And after that, I used the Roberta Go Emotions models, which was already on the website. And at last, I used the Roberta baseline model. The fine-tuned mental BERT model used binary cross-entropy loss with class weighing, and I trained it for 10 epochs. I kept the evaluation metrics like micro F1 and accuracy. These models basically detect emotions such as joy, sadness, anger, fear, and another simultaneously per posts. After that, when I ran the models and I got back the results. And the results showed that the mental BERT has achieved the highest performance with the F1 score of 0.67 and the accuracy of 0.68, which outperformed both the Roberta models. And the Roberta with Go Emotions achieved a very less F1 score of 0.45, while the base Roberta scored 0.55. After that, I did the Ekman level aggregations, which was basically grouping all the 28 emotions into the 6 emotions, taking the neutral as the seventh emotion. And it shows us that the sadness emotion was 31% and the fear emotion was 11%. The sadness was dominant in the dataset, while the surprise consisted of all other emotions and it was 23%. This validates our fine-tuned model captures the emotional core signals of psychological distress. After emotion classification, I wanted to move beyond categorical labels like joy or fear and understand how these emotions vary psychologically in terms of intensity and positivity. To do this, I used the circumplex model of effect. which represents emotions in two-dimensional space, valence on the x-axis and arousal on the y-axis. Valence measures how pleasant or unpleasant an emotion is, while the arousal measures how calm or activated someone feels. For example, calmness has the high valence but low arousal, while fear has the low valence and high arousal. I applied the NRC and VAD lexicon, a database assigning valence and arousal and dominance scores to around 20,000 English words. Each post was tokenized, and every word's valence and arousal scores were averaged to get an overall effective position. These points were then plotted on the circumflex space to reveal patterns of emotional tone in user generated text. The advantage is that this approach grounds our model's output to psychological theory rather than purely computational labels. Ultimately, this mapping let us see how activated or positive a community's language is. Moving on, when I plotted after the results, as you can see, this figure shows the valence arousal distributions of approximately 35,000 Reddit posts. Each blue point represents one post position according to its average valence and arousal score. We can see that most points cluster around valence 0.55 and arousal zero point 0.5, meaning users express moderately positive but emotionally activated states. However, the cluster is slightly tilted towards the negative valence region, suggesting a dominance of sadness, fear, and stress related language. Smaller, denser groups near the center correspond to the neutral or mixed emotions, whereas outliers in the top right quadrant indicate brief moment of hope or excitement. This distribution supports the earlier Ekman level findings, where sadness and fear were most frequent, but also reveals arousal variability, showing that not only negative posts are flat or apathetic, many are emotionally intense too. Psychological, this pattern aligns with anxiety dominated discourse where emotional engagement is high despite low positivity. Moving forward for the conclusion, I have achieved four objectives of my project: the data collection, sentiment analysis, emotion and symptom detection, and the emotion mapping using the circumplex model. After which, I plan to extend this framework in several ways through psycholinguistic profiling using Empath and DLA-TK library to capture linguistic features like self-focus and cognitive load. Next, I will do the temporal emotion trajectory analysis, which will track the emotions with the subreddit and the users along with the time. After that, I will do the network modeling, which will connect symptoms and emotions across the users. And at last, I will do the cross validation, in which I will compare the Reddit and Beyond Blue data to identify platform specific mental health language differences. Moving on, these are the references which are the primary academic resources that supported the models and methodologies, including Mental But Roberta, Go Emotions, and the circumplex model of effects. Altogether, these works form the foundation for the integrated framework I have developed. So, at last, if you have got any questions regarding my project, please feel free to reach me and contact me on my email, which is listed on this slide. I hope you enjoyed the presentation, and this brings us to the end of this presentation. So, thank you for your patience and listening.